Hello students. In this set of notes we're going to be looking at topic 6.6, which is kinematic problems. So kinematics involves displacement, velocity, acceleration, and then we're going to distinguish between displacement and total distance traveled. So displacement is how far we are from a fixed point. It's also a vector quantity, so it will tell us if we're above or below, left or right from that fixed point. So we're always assuming we're traveling in 1D in this context. So with example 1 here, we're starting by looking at a rock being thrown straight up from a bridge, and it's following this equation. So let me change my color here. So when we look at what's happening, we've got going straight up and down. Here's my equation. So I want to look at the points so I know what to graph. So I've put that into my calculator. And we can see we're going from 25 up to 35.1, 35.4. So I'm assuming that my max is happening either between 2 and 3 or between 1 and 2. Of course, I could do some algebra to figure that out. So we've got, let's just count, let's say that's, let's count by tens, maybe. So 20, 30, so we know we're starting at 25, at about 1, let's count this as 1 over here. So we could say that one was 30. At 1 we were up around 35 or so. At 2 we were also around 35, maybe a little bit higher than before. Then back near 25, so just above 25 over here. And then right above 6. And then at 5 seconds, we had come into negative territory. So let's go ahead and find our max. So let me first think about my window. Let's go -1 to 6. And it looks like we can have our min go from about -50. And let's go up to about 50. Counting by 20s is okay. So here's my parabola. Looks like my max is between 1 and 2. So let's go ahead and find it. So I'm going to say left bound is 1, right bound is 2. My guess is maybe 1.8. Okay. 1.5 and about 36.5. So just above where I'm at here. Try to make a smooth picture if you can. And we know that we're ending up somewhere down here. So here's my initial position. It tells me to label that as I. So that's also going to be 0, 25. So basically this is saying that the bridge is 25 meters above the ground. I've got meters over here. I've got seconds over here. The rock pausing in the air. So basically at this point, my maximum, so that's R. So basically we throw the rock up, it pauses for a brief second of time and comes back down. Slope of the tangent at that point, so I'm going to call that M sub R. That's of course 0. That's my maximum. The range of time where the rock is moving up. So it's moving up from 0 until I hit that maximum. So my range U is in this area. I could say U is X such that we're going between 0 and 1.53. Oh, sorry. In this case, I'm not using X, I'm using T. So I'm going to say less than 1.53 because I know at 1.53 that's my max. The range of points where it's moving down. So moving down, that's happening from this area. So we're moving down for T such that we're between 1.53 and 5. And I'm stopping at 5 because that's where we wanted to look. So I've got my bridge, maybe it's above a river, that's why we're going below ground. So my position at 2 seconds and 1 second. So at 1 second, let's come back to our table. I'm gonna drag this over here. So here's my values. So at 1 second, I've gone 35.1, and at 2 seconds, I'm at 35.4. But really, when we're thinking about how far the rock has traveled, we know that we've gone from 35.1 up to the max, and then from the max down to 35.4. So let's come over here, and we had calculated our maximum. So that should be stored in our y variable. So if we say alpha y, let's see what happens. There's my actual maximum value. So I'm going to find the distance. So I know that starting from 1 second, I was at 35.1. So I'm going to take this value, subtract my 35.1. I'm also going to take this value and subtract my 35.4. And now together, the sum of those is the total distance traveled. Notice this is different than the displacement. If I had just looked at the displacement, I might say that it had only gone 0.3 meters. But really, my rock went a total of 2.46 meters. So that's my distance traveled as compared to my displacement. So if I had just talked about displacement, I would have said 3.3 meters or 3/10 of a meter. So displacement, change in position, total distance is going to be how far we've actually gone.